I would love to start with asking you, what is your story, Lena?
From very early on, I knew that I want to become a scientist. When my professor approached to me and asked if I want to start up a company with him.
So you are a scientist and a businesswoman. Sounds very simple yet very profound. And for researchers, what are the things that they need to focus on when having such a collaboration with a company like yours?
Holding on to the results until the IP situation is solved, I think that's really critical.
So you're actually looking for an innovative idea that has not been published and they become rich.
Yes.
Hopefully. Piece of advice for somebody who's going to start in the diagnostic field and actually commercializing their innovation.
You need to be open for new possibilities, so you never know what life brings forward. So be open. When you have an idea, make sure that there is some kind of unmet need in the market. Unfortunately, sometimes the idea is great, but then there is no real world need for it.
According to business studies, 90% of mergers fail. Aren't you worried you'll be replaced? It sounds like you're building a very strong relationships and trust. You're showing them like this is the quality that we are and you're standing by your, like you said, your value.
For example, with ovarian cancer, it's one of the deadliest cancers among women.
How hard was the change from being a scientist to becoming in the business field?
Because I always knew I want to be a scientist, and then suddenly I was not. Looking back, I wouldn't change a thing. You never know what life brings you, so be open for new possibilities and seize them, because they might lead to something even greater.
Given that we're science pitchers and we love scientists to pitch ideas.
So you need to have the people that are doing the science, and you need to have resources to do it.
Lena, Kokko. Such a pleasure to have you here with me today.
Thank you. It's nice to be here.
Happy to hear. And I would love to start with asking you, what is your story, Lena?
You mean how I became a scientist? Yes. Well, I think I'm very lucky because from very early on, I knew that I want to become a scientist. So I was very intrigued by how humans work and how cells work. So I remember when I got a microscope for my Christmas present, I spent entire vacation time trying to carve a hole on the side of my thumb, trying to get a drop of blood out of it using very dull needle because I was afraid to ask a sharper one from my mom. And well, it was something that I wanted to do. So after high school, I was very happy when I got accepted to University of Turku. I started to study biochemistry and then specialized in biotechnology. So it was quite a clear path from quite early on.
It's very early on.
Yes.
From the moment you were drawing your own blood
Yes.
to study. Wow. It sounds like you're a person who's very curious and also trying to work with what you have. Very resourceful.
Maybe, yeah.
Thank you for sharing this. And how about the story about Uniogen? What is the story behind
Yeah.
that?
Well, I was doing my PhD at university, and I was actually just starting to write the thesis when my professor approached to me and asked if I would want to start up a company with him. So he had this business idea, and he was building up a team to start to do it. So that's how I became managing director of Kaivogen. And then we operated for 15 years and then went through a merger with two other Finnish companies, and then we became Uniogen, and now I'm the head of oncology at Uniogen.
Head of oncology.
Yeah.
That's fascinating. Can you tell me a little bit about the work that you do?
Well, we are developing new type of cancer assays that can detect cancer at earlier phases. We are focused on ovarian cancer at the moment. So basically, we have a team doing the science part, and I'm kind of heading the business part of the project. So finding partners and finding the routes for commercialization.
That's beautiful. So you are a scientist and a businesswoman.
Well, I think I'm more of the businesswoman at the moment, but I think that having a strong scientific background definitely helps, because when you are talking with, for example, investors and potential partners, they want to know about the science behind it. So having a kind of scientific background definitely helps in that kind of thing.
Definitely.
Yeah.
And now that you mentioned that there's a little bit of a merger that happened, so I want to understand, so what does Uniogen do exactly today?
Yeah, well, we have quite, I think, comprehensive product portfolio at the moment. So at Kaivogen, we were focused on immunoassay development and component manufacturing. And then through merger, we also got molecular diagnostics from a company called Abacus Diagnostica. And then we have the instrument manufacturing and development as well from Labrox. So now we are offering both immunoassays, molecular diagnostics, and also instrumentation. So it's something that we couldn't do as individual companies, but now we have this more comprehensive product portfolio for our customers.
It's quite comprehensive. You're sort of taking the entire journey.
Yes. Yeah.
Okay, so what would that, for example, if we can say it to somebody who's not an expert, what exactly that you sell?
We are doing a lot of component development and manufacturing at the moment. It's called CDMO. So it's contract development and manufacturing organization. So basically, we are producing all the bits and pieces that are needed for diagnostic assays. So we are making, for example, protein-coated plates. We are making buffers. We are making conjugations, and then also instrumentations. And that's something that we are selling to our customers that are IVD companies, and then they are using in vitro diagnostic companies, and they are using them in their own products and selling them under their own brand. So our brand is not visible for the end customer at the moment. But we are also doing a lot of proprietary product development at the moment also, and that's for the early detection of cancer. So something that we are developing and then planning to commercialize ourselves as well.
Oh, wow. Okay, so at the moment you are doing the manufacturing?
Yes.
And you are sort of like white labeling it to people.
Yes.
Right? If they want to add their own logo on it, then you're sort of behind the scenes developing that.
Yes, exactly. Yeah.
And can you tell me more about what do you mean by proprietary product development?
So we have IP, so patents that are covering different cancer assays. So basically how to detect these cancer-specific sugars that are present in blood sample if a patient is having cancer. So we are making assays that can detect these cancer-specific sugars, and then making this kind of accessible and affordable way to measure it, and then planning to commercialize it as a diagnostic kit.
That's fantastic. Yeah. Sugar, what did you call it? Sugar cancer?
Cancer-specific sugar. So
cancer-specific sugar.
Yeah, it's called glycosylation. So that's something that proteins undergo when they are produced. These kind of sugar groups are attached to the protein. And if the glycosylation is happening inside cancerous cells, the sugar groups are different compared when it's glycosylated inside healthy cells. So by detecting these cancer-specific sugars, we can definitely see if the patient is having cancer and not some kind of benign condition. For example, in ovarian cancer, endometriosis is usually elevating these kind of proteins that are also related to cancer. So that's why elevated protein concentration might mean cancer, but also endometriosis. But by detecting these sugar groups, we are detecting cancer and not the benign conditions.
That's a fantastic idea. It sounds very simple yet very profound, because you are checking for very specific things using your diagnostic product, and then you're able to know, okay, what is the cancer activity in this patient, and is there something or not?
Yeah.
Now, I'm very intrigued to know, how did this happen? Like, how do you move from an idea to an actual product?
Yeah, well, in this particular case in cancer, we are actually very, very happy to have collaborated with University of Turku. So the basic research and the idea is coming from the researchers from the university. So they started their own development work. Actually, I think it was back in 2016, maybe. And we were part as like a company collaborator, part of the project. And when they made this invention and found out this cancer-specific glycosylation and a method to measure it, they filed IP, and then it became available for companies to purchase it. So that's when we purchased it and started our own development work that is now leading to the commercialization of the idea.
Oh, that's fantastic. So you actually have been looking around in the research that is being done here at the University of Turku.
Yes.
Ah.
Yeah.
What do you usually look for when you do that, when you're looking for existing IPs?
Well, of course, it has to fit with our strategic focus. Okay. So something that we are planning to do. And in this cancer diagnostic, we know that the group at Biotechnology is really focused on that. So that's something that we have collaborated from the beginning, actually, with them. So being able to be part of their research and follow how they are doing things, I think that has been really, really helpful. And when they are doing the early phases of the research, then we can start up the actual development that would lead for commercial product.
So it seems that the timeline is a bit long.
Like it takes several years usually, yes.
Several years?
Yes.
Like how several?
Well, with this ovarian cancer, we started our own development work back in 2018, and now we are in 2024, and it's available for research use. So it's not yet available for clinical use. So that is going to take another 2 years.
Okay, so roughly we're talking about 7.
Yeah, it has been a very long route. I think that, of course, it was the first this type of product that we were developing. We are planning to broaden the portfolio further for other cancers. So for that, I think that the route is not going to be that long, but it's still going to be quite a few years.
Quite a few years,
Yeah.
that is true. Then it sounds as if you started already early on, then maybe you had some sort of a collaboration with those researchers. Were you funding some of their projects or?
Yes, it was actually this kind of quite often in university when they are applying funding for Business Finland, for example, there is this company involvement. So we were part of that kind of collaboration as a company. And there are different kind of consortiums as well. So different companies and different university groups can file funding, for example, from Business Finland. And then they all have their own individual projects, but there is some kind of like a something in common with what they are trying to research. So in that kind of consortiums, we've been part of quite a few times.
You've been quite a few times.
Yes.
So what do you usually look for? What are your needs as a company?
I think that we want to support the work that university is doing because, like I said, they are making great innovations. They are doing the early phases of the research, and that can, in the future, lead to something that can be commercialized. I think that being able to support what the university is researching is very important for us. And of course, it might lead to something that can have this kind of commercial use for us in the later phases. I think that's, of course, interesting as well.
Definitely is.
Yeah.
And for researchers, what are the things that they need to focus on when having such a collaboration with a company like yours?
Well, I think one major thing is that you can't really publish anything until the IP situation is solved. So that's something that might be difficult for university, remember? So because in company world, having patents and having IP, that's really important when you are looking for licensing opportunities and things like that. So holding on to the results until the IP situation is solved, I think that's really critical. And then after that, making the publications.
Okay, so you're actually looking for an innovative idea that has not been published?
Yes, so you can look at the like patent coverage of it as well.
And do you support with these patents when you're collaborating or?
Well, usually in university, the innovation services, they are offering them out for companies, so we can purchase it and then become the owners of the patent. So, and then of course being responsible for all the patenting costs as well. Then,
of course, then I think the university then would own the patent.
Well, if the university, there are different types of deals that you can make. So the university can license it out or then just to sell it out. But usually some kind of royalties are also involved. So the innovators, the people that have actually made the innovation, then they are entitled to having royalties for the future sales.
Yes, then they become rich.
Yes.
Hopefully.
Maybe.
So they get to impact the society and also they get to reap the fruits of their hard work.
At some point, yes.
What would you say is one of your expectations as a company when you enter such a collaboration with an innovative research group?
Well, close collaboration, of course, having open communication both ways, it's very important.
And I feel that this open communication usually needs some sort of contracts to be set in place.
Yes, that's true. Yeah.
So what kind of contracts do you usually look at?
Well, if there is some kind of materials that are transferred, then you need MTA, so material transfer agreements. And then, of course, in early phases, NDAs to make sure that the confidentiality things are in place. So people are not, usually in NDA, it's clear that who is owning the background information and then what happens for the foreground information, the new information that is generated during the process. So those kind of things are then kind of stipulated in these agreements.
Can you tell me a bit more about the foreground information? What does that really mean?
Well, during the project, when you are making these innovations and finding out new things, then who is the owner of those kind of new ideas that are coming? So the background is something that, for example, companies and universities already have when they are starting the collaboration, and then the foreground is something that is generated during the process.
Who would be the person who's in charge of this or who owns the rights of the new foreground?
Well, it's something that is then agreed when you're making the agreement. So it's something that needs to be stated there. So
there's no like one size fit all approach. It's
no,
always
no.
like the company or the innovator or the university
No,
or
of course, universities have their own like drafts and templates that are used, and that's something that is usually the starting point when you're negotiating.
you're negotiating with them.
Yeah.
And it's so beautiful to see that how, I mean, it's counterintuitive because you're telling researchers not to publish their data and to be kind of secretive about it because that's how you actually have a patent and you can protect your idea. But at the same time, you're also still protecting your idea in a way that the collaboration needs to be well defined.
Yes.
Well, what would you say then is, from your extensive experience in this field and in collaborating with researchers and innovators, what would you give let's say, a piece of advice for somebody who's going to start in the diagnostic field and actually commercializing their innovation?
Well, I think that you need to be open for new possibilities. So you never know what life brings forward. So be open. And when you have an idea, make sure that there is some kind of unmet need in the market. So making sure that there is something that the customers, the end users are going to need. So for example, in clinical world, that there is some kind of solution or problem that needs a new kind of solution. So unfortunately, sometimes the idea is great, but then there is no real world need for it. So that's why you have to have this kind of problem that needs to be solved, and that's the good starting point for a new project to trying to solve some kind of a problem that is already out there.
Is relevant.
Yes.
Absolutely. Thank you so much. This was very very spot on actually.
Thank you.
Thank you. So then if we can dive a little bit more when it comes to, you said there was a merger after 15 years
Yes.
of your working alone. How did that merger go? Because we hear that according to business studies, 90% of mergers fail. So how did you make this work?
Well, we haven't failed yet. Yeah. So I think, well, first of all, we are all local companies, so all based here in Turku, and we had several years of collaboration already behind us. So, for example, with Laprox, we were developing this kind of new detection method of upconverting nanoparticles. So basically, Kaivogen was doing the chemistry work, and then Laprox was doing the instrumentation work. So it was something that we had collaborated for, well, actually 10 years before the merger. And then with Abacus, the molecular diagnostic company, we were doing certain production parts for them. For example, during the pandemic, the COVID pandemic, when there was a huge need to increase the production capacity of their products, we were part of the production kind of process, making certain things for them so they could increase the capacity. So I think that having this very, very long collaboration made things very easy. We know that we had shared values and we had this vision that we want to do more. And then knowing that a small company, it's quite difficult to do more, and merging and this kind of having a little bit broader shoulders would make it easier. So I think that we had a very kind of like a common idea how to move forward. So that was a very good thing.
It sounds like a very successful merger, actually.
It has been a lot of work, I have to say, and it's still in a way ongoing because we are all operating under ISO 13485, the quality system. So there are still some documentation that are not yet like made common. So we are using certain documentations that were made for one company in certain phases of the production, for example. But it's something that it's ongoing, and hopefully that will be completed within this year in 2024.
Hopefully. Wish you all the best.
Yeah.
You're almost there. And maybe then I want to understand something about the merger. So you said you're adding to them sort of the manufacturing side, so the quality that they need, and they're adding to you the funding. Did I understand this correctly?
No, not really. No, I think that we all had our old businesses had customers. So I think that we all were giving something. We weren't competitors in a way because we were all operating in separate fields. But now by combining the know-how, we can do more. So we can offer better solutions for our customers. So I think that we are all contributing for the manufacturing, and we have different manufacturing capabilities in a way, but they are all complementing with each other. So I think that's very good. And now when we are a larger company, we are able to find different funding sources that were not that much available for smaller companies. In a way, for example, this kind of investor funding and things like that.
Of course, you're much bigger now. Yeah, the scale is very different.
Yeah.
Now, how about you mentioned something about the manufacturing and how you were manufacturing without adding your logo on it.
Yes.
Aren't you worried you'll be replaced?
Well, in diagnostic world, usually the products are very, very regulated, meaning that when you are making a clinical product, you have to go through this really long regulatory route, and meaning that all the components need to be tested to really prove that the product is working in a right way. So having this kind of product development and manufacturing in this kind of product, it means that it's quite difficult to find a customer that would like to change into your component. But then again, if you have a customer that is using your component, they don't want to change because that they would have to go through the whole regulatory path again. So that would mean a lot of time and money wasted. So that's why once you have a deal, that's quite secure. But of course, customers might decide to end a product totally and things like that can happen. But still, having this kind of regulatory environment where you are working, I think that makes it quite difficult for them to change a component manufacturer. And of course, we want to make sure that our customers are very satisfied and we are offering them the best quality product, and they are very happy with what we are offering them.
What you're offering. And
yeah.
How do you avoid them kind of moving away and going to another competitor?
Well, like I said, it would be very difficult for them to change a product, and then offering them a very high quality products, meaning that they want to use us also in the future in their new products. I think that's something that is very, very important and something that we have been quite successful doing. So I think that the risk of losing customers has not really happened in the Uniogen or Kaivogen history.
It sounds like you're building a very strong relationships and trust. You're showing them like this is the quality that we are, and you're standing by your, like you said, your values.
Yes.
Then I'll ask the question the opposite way. How do you actually get them on board? If it's also such a hectic process of getting the approvals, like how do you do that?
Quite often we are targeting customers that are still in early phases of development. So startups, for example, meaning that they are looking for usually startups don't have that high production capacity, so they want to outsource certain things. So trying to find those type of customers has been kind of the strategy. But of course, it will then take quite a few years until they have really entered into the market and having a larger need for the product as well. So it takes quite a lot of patience in a way, but that has been the way that we've been doing it. So finding customers that are still in early phases and doing active development work in their production, and then being part during the already in R&D phase.
R&D phase. What would you say the timeline would be for such a collaboration?
You mean from the start to higher volumes? Usually, again, it takes quite a few years. Yeah.
I feel like we're talking 5 years, for example.
It can be something from 2 to 5 years. Yeah.
From 2 to 5 years, generally. Yeah. It seems like the name of the game is sort of like planning, strategy, and patience.
Yes. Yeah.
Nothing happens like that.
Yes, that's definitely true. Yeah.
Lovely. And what would you say is the mission now? of Uniogen? What's their vision and mission when it comes to oncology diagnostics?
Well, we want to offer tools, diagnostic tools that offer better life to the customers. So that's the goal. So basically, what we are doing both in this OEM field, meaning when we are making the products for our customers, and then our own products, we want to do something that really has a positive effect in people's lives. And for example, with ovarian cancer, it's one of the deadliest cancers among women. It's usually diagnosed too late. So when the cancer has already spread, it means that it has a very low survival rate. Less than 50% are alive after 5 years of diagnosis. And all the clinicians and key opinion leaders are confirming that there is a need to find better biomarkers that can be used in early diagnostics of ovarian cancer. And that's something that we are now doing. There is an unmet clinical need, and we are offering a solution for it.
That is very beautiful. Thank you. Thank you so much for sharing this. And I think this is bringing me to one question that is really bugging me here. How hard was the change? And I want a very personal answer here. How hard was the change from being a scientist to becoming in the business field?
I have to say it was very, very difficult in a way, because I always knew I want to be a scientist, and then suddenly I was not. But then again, looking back, I wouldn't change a thing. So I'm very happy the way things work out. So I think, and that was one of the ideas, that you never know what life brings you. So be open for new possibilities and seize them, because they might lead to something even greater. And I think that what I'm doing now, I am enabling people to do science and being able to be part. I'm still in R&D meetings whenever I have time, and contributing even sometimes something, but being able to hear how things are progressing and moving forward, and knowing that if we are successful, we can actually save thousands of human lives. I think that's really, really great.
It's beautiful. It sounds like you're an enabler of science.
That's the way I'm thinking it, yes.
Oh, regardless of where you are. If you're doing the science, if not, then someone else will do science and you will support them.
Yes.
If I can tell you in 30 seconds, given that we're science pitchers and we love scientists who pitch ideas, in 30 seconds, how would you pitch the idea of somebody taking also your footsteps and moving from being a scientist to an enabler of scientists?
Oh, that's difficult.
How can you convince them to do that switch?
Yes. I don't know how to answer that. I have to think about it.
Sure, take your time.
Yeah. I think that if you're looking at the big picture, you need to have all kinds of competencies. So you need to have the people that are doing the science, and you need to have resources to do it. So if you are able to help in either way, that's equally important. So finding a way how to move things forward and finding new solutions, I think that you should consider all aspects of that, both in the resources part, and then doing the science work.
So kind of balancing it and doing the best in your situation, being resourceful.
Yeah.
It sounds like mini Lena when she looked around for some sharp object to get the blood out. So do your best in with what you have. Kiitos paljon. Thank you, Lena. It has been a pleasure to have you with us.
Thank you.
Thank you so much.